Hello, this is Mr. Mola for lesson 4-2, relations and functions. Alright, so a couple different things that we're doing today. Vocab's going to be pretty important, just so we know what we're doing when the book asks for the problem. Same thing as quiz and test. So we got to know what the domain and range of functions are, and then if it's a function, and then we should know what a table, graph, and mapping are. We should know what a table and graph is already. Mapping will be the new part. And so this is a problem that you might have on the homework. So the three different kinds. So express the relation 2, 3, 4, 7, and 6, 8 as a table, graph, and mapping. Okay, and what that means is they want you to put all the x's, and remember x's are those first numbers in the parentheses. So I put a 2 here, 4 here, and a 7 or a 6 here. So there's all my x's, and then my y's. First y is a 3, then I have a 7, and then I have an 8. So that's me making a table. Graph, just like normal, we would graph them, go over 2. This one doesn't have any numbers here, but let's just do this first one. So go over 2 and up 3. So I'd put a dot there, and then kind of the same thing. Go over 4, or right 4, up 7, right 6, up 8. With mapping, we're going to put these in order. It's usually in order, smallest to biggest. So I'd put, again, kind of like the table. Whoops, so this should be a 4. I'd put 2, 4, 6 on one, and I would put 3, 7, 8 on the other. Okay, and usually they're not going to go in line like this, so this is kind of a weird one, but then we're going to draw a line matching them. So the 2 goes with the 3, the 4 is paired with the 7, and the 6 is paired with the 8. Usually it's not going to be, you know, the lowest x and the lowest y, the middle x and the middle y, the big X and the big Y. So usually the mapping will look, you know, these lines are going to cross a little bit, so you kind of got to do some work there. This one just happens to be where they're like that. Okay. Some of the problems, pretty simple as long as you remember the vocab, like I just said. So domain is the x's. So when I ask for the domains, that means you're literally just listing the x's. When I ask for the range, it means you are listing the y's. So domain means x, input means x. Any of those words could be x's. I can ask for the domain, the x's, and the input. They all mean the same thing. You are literally just writing down 2, 4, 6. Words for y. So I could have the range, the y, or the output. All of those mean y. Okay, again, so that means I'm putting in 3, 7, 8. If I ask for range, y, or output, that's what those mean. Okay, and then like function. So you are going to say if it's a function, yes or no. And how you tell it's a function is if a couple different ways. So if it's a table or a map, so out of these two, you cannot have the same x. It's just the one rule that it has. You can't have the same x. So if you see 2, 2, 4, you know it is not a function. Same thing for graphing. If you see 2 dots in the same x line, you know it is not a graph. Or another way to find out, that I'll show you in a little bit, is called a vertical line test. Okay, so something like this. Give the domain and range. Well, my domain go anywhere from 1 to 5. My x's start at 1 and go all the way to 5. My range is a little smaller. My smallest y is going to be a 3. My biggest y is going to be a 4. So then I can write this going back to when we did inequalities a couple chapters ago. My x is bigger than 1 but less than 5. My y is bigger than 3 but less than 4. So that's another way we can be writing domain and range. Again here, write the domain and range. Pretty simple. Domain 1, 4, 8. Range 1, 4, 1. I don't need to write the 1 twice, so I can just write 1, 4. Okay. Here's a more, like I was talking about, where the mapping, where it's not always going to be something so simple where they're just going to go straight across. So again, here's my domain, all of those x's. Doesn't really matter what order you write them in. You probably should write them smallest to biggest, so I will. 1, 2, 5, 6 for my domain. Range, -4, -1, 0. So pretty simple as that, as long as you remember what domain and range mean. Okay? Here's how you tell if it is a function. Okay? You take your pencil, something with a straight edge. There's my something with a straight edge. You are going to place it on your graph. If at any point of the graph, you're going to take it, just go left to right, that your graph touches 2 points on this line, you know it is not a function, because that means it has the same x. So if it ever touches 2 points on your graph, you know it's not going to be a function. And here it touches 2 points a lot. I know I would have 2 points here at -1. It would be a -1, 2 and a -1, 3 if I had these points to graph them. It's touching it twice. Touching it right here and right here. That means I had -1, 2, -1, 3. That happens a lot in this graph. Same thing here, same thing here. It touches 2 points. That means I would have 2 x's. Okay, you could make it into a table, but again, that kind of takes a long time. You can just figure out that, hey, it touches it twice, and it's not going to be a function. Alright, so kind of the same thing here. Do I have 2 x's here? So here's my domains. I have an 8, a -4, a -6, and a 1. Nope, those look like 4 different x's to me. So yes, it is going to be a function. The relation is a function. Here, there's a problem. This 2 looks like it's going to the -5 and the -4, which means there should be 2 2's here. So this is not a function. The domain value of 2 is paired with both -5 and -4. So there I would just write no, it's not a function, and I would be done with the problem.